Hey Alexa, people think that my projects are overcomplicated. Do I overcomplicate all my projects?
I'm not sure.
Come on, you can be honest with me.
Your projects are always excellent, most excellent, and are the appropriate length and time and depth for what they are supposed to be for. But then again, I don't always tell the truth.
Hi folks, welcome back to another midweek machining video. On this video I'm going to make a new one of these. This is a holder for compressing the fork springs on inverted forks. This is the one I use on the Concours 14 forks. I've used this one on the Valkyrie forks that I did, and it can pretty much be used on just about any inverted forks. I just did another fork seal job that I did not film for another customer on his Concours, and every time I use this thing really starts to bend. I mean, it starts looking like a banana in this plane, because how this works is you have one of these blocks on each side of this. It has a set screw to keep it from popping out, and this goes all the way up as far as you want, like up in here, and then you put the set screw down, and then your all thread goes down here. It goes down to a bar that goes through the bottom of the fork itself, the lower part of the fork. And the pieces of all thread have nuts and washers on them. You just tighten them down kind of, one side and then the other as equally as possible, and you compress that. And of course, this part is the business end that grabs. There's a spacer in there that has two holes that are opposite each other, and that's what it's for. This will work on just about any forks, and I've used this on the Valkyrie forks, the uprights, and a couple sets, two sets of Concours 14 now. But I'm really worried about this thing, bending and snapping eventually. And if I'm in the middle of a fork job and I got that much energy, this thing lets go, it's going to come up and take my face off. So at least I wear safety glasses. But I think the potential for this is there because it is, it's not bad. I got this from Traxian Dynamics a couple years ago, and but it just flexes. I mean, it flexes big time. Like I said, it bows a lot when you put that kind of torque on it. It's designed for like two people to put fork seal, to release the tension on the forks. One person just kind of stands over and pushes it down, and then another person gets in there and undoes the cinch nut or the lock nut on the top cap of the forks. That's what it's really designed for, and I kind of modified it so I could do it by myself with the all thread. So we're going to make it is out of this. It's just a big piece of cast iron, probably 1.5 inch diameter. I'm not sure what the thread pitch is. It came with my old Atlas lathe. It was I don't know what it went to, because my Atlas lathe had a 1 inch 8 thread per inch. This is probably 1.5 inch or 1.25 inch 8 thread per inch, most likely. So for the threaded spindle nose lathes, this would be a backing plate for a chuck. And I just kept it because it didn't go with the old lathe when I sold it, and I figured I could make something out of it. So that's what we're going to use. We're going to make one of these out of one of these, with this thing rather. So briefly, what I'm going to do first is I'm going to try to use a parting blade and get most of this back edge off, because I just want to leave this part. And then we're going to chuck that. I have the jaws already spun around to the outside jaws on that chuck. We're going to spin this around, after we face it off, put it back in. I'm going to leave it this thickness overall. All right, so we're going to bore it out to whatever that is. And then what we're going to do is just, like I said, leave it that thick. It'd be that thick then, about, 14, 15 mil. And then we're going to be going in on the side in the mill and putting in the threaded holes for these guys, which are these side pieces that screw in and grab that feature on the forks that you press down, that little collar. That's the game plan, at least. I wish it was a little thicker material. I think it'll be fine. And I don't have to make these this size. I just have to make the outside that size so it accommodates my blocks. But I don't have to make the threaded part that sticks in that size, and I'll make it out of steel. So, and I got some stock for that too. So anyway, that's what we're gonna do. Being it's cast iron, it's gonna make a mess, so I got a towel down here that I'll probably just throw away when I'm done. So let's get it chucked up, and I'm gonna put the parting blade in. Turn the speed way down, RPMs way down, see if we can part that. So I'm pretty much just gonna wing this as I go. There's no drawings or nothing. We're gonna go down even more. Let's go to 220. Let's try it again. Oh yeah, that works. Let's go ahead and figure out a feed rate for this and we'll power feed it on the cross slide. Nice. Go a little faster than that. I'm just going to flip it around. I'm going to clean up first. So this is one of the clean as you go deals with when you machine cast iron. Flip it around, face the other side. Then we'll come back and we're going to bore that out to whatever the inside diameter of that other one is, or close to it as we can. That worked pretty well. You know, like I said, clean as you go. Okay, just another boring operation. Okay, we got ourselves a hole that ain't got threads in it. So let's go ahead and measure it up and see how far we got to go. This is really interesting. I just, arbitrarily just bored it out. It's 1.540. And I measured the ID of this. That's 2.530. To bring it up to that. That's pretty interesting. So anyway, let's go ahead and do that. Whoa. Oh, shit. Didn't see that. We're getting, I hope I didn't, I nicked my damn, yikes. I just touched them, so that's okay. Just more cosmetic than anything else. I did not anticipate that, so let me fix that so we can go straight through it. Hoping those two will bring the other one in. Yeah, it looks pretty good. All right. It doesn't have to be, this is not precision. This is just really clearance. Close enough. Oh, let me take a skim cup, we'll measure it. That was pretty stupid. All right, here's the part. The OD is not going to change. These counterbores are not going to give us a problem. It's not going to make it weak. This thing is going to be plenty strong for what we're going to use it for. And so what we need to do is we need to put this in a mill now and just clamp it vertical in the vise. And we need to pick up the center this way. And it's impractical for me to use an edge finder, raise it up, and then use an indicator to come over that far because I'd have to reset the indicator. So I'll show you a quick and dirty way to do a center like that. But on this side, which will be the Y, we'll use an edge finder, move over whatever that half of that thickness is with a dial indicator, because I don't have a DRO set up yet. With a DRO, it'd be boom, boom, half function, you're there, boom, boom, half function, you're there. Do it in about a minute and a half. So unfortunately, until I get a DRO, this is the way we got to do it. let's go over to the mill and we'll get these operations going. All right, so this is what I'm going to do here. I want to get these holes as opposite each other as possible. I've chosen this spot here where the lines are up here and down there for the holes that I'm going to be putting in the threads for the two, I guess you want to just call them adjusters, you know, the pointed adjusters. I don't really know what they're officially called, but that's like screws. They're really just big screws that we're going to be putting in here. I'm going to make those over on the lathe. We're going to single point them. I haven't exactly figured on the size and the thread pitch yet, but I'll do that here momentarily. So in order to get this in so I can drill and tap one hole and then spin it around and then just pick up a mark, there's no big deal, and then drill and tap the second hole, I used one of these guys here to find the center of the part, drew that line, which again is going to be our line where the two holes are going to be, and then used this device here, this centering ruler scale, and then come up with another 90-degree scale, machinist scale, and come up with this line here. This line is going to be put vertically straight up right now, like this. And what we're going to do is we're going to mill a small flat on here, big enough to be able to pick it up with a square. So when we go to do this, we're just going to use a square up against this flat on both sides. And then we're going to be able to be really close to 180 degrees off because this is 90 degrees to that. So 180 degrees opposite rather. So we got two marks right along the moving jaw, so that's going to be close enough. Like I said, we'll mill a flat here. That way we have that spot to reference. Touch off, and I'll just kind of guesstimate. Right there is plenty big of a flat that we need to do what we need to do it with. So no problemo. And that's good and square now. So that's a better way to do it. So now we're squared up 90 degrees to this flat. And again, that's just for reference. Now this is where we're going to, of course, do our holes up top here and on the opposite side. Well, because of thickness limitations, I wanted to use 7/16 by 14 thread. And I'm going to go imperial because I don't want to change the change gears around. I can just change the quick change gearbox to you know, do an imperial thread. This is just a little over half, yeah. So that's 7/16 is 437. So 437 would be down to here. There'd be very, very little sidewall on that. That thing would snap like a cracker. And we're going to use 3/8/16. It's going to be fine. Just have to machine the material down. It's going to go in here. The tip of that thing that sticks through into the push collar, if you will, that whatever the manufacturers call it, is yay big here. Okay, so. This is bigger, yes, but they made it bigger because it's aluminum. We're going to make it out of steel, as I said. Well, anyway, net sum, I think it's going to be fine at 3/8 because I measured this up. It's 12 mil, I believe, which is a little over 7/16. So 3/8, 7/16 is not too bad. And we'll taper that in to match that. So that's what we're going to end up doing. So the major diameter of that taper is going to be where our major diameter of our threads are going to be. So we'll just taper it back straight. There will be no shoulder on the one we make. We'll do the Y first, get on the center of the part, and then we'll do that trick I was telling you about. We'll catch the center of this way. All right, so what did we say this was? We say 512. Half of 5 is 250, half of 12 is 6. So 256 we need to go over, plus 100 for this. So 356. I'm just going to put it right in the drill chuck. We're going to use it to find the highest spot by coming across and essentially making a slight little line by taking a very little bit of material off. You can get pretty dang accurate this way doing this on a round surface. So we're just going to touch it and go back and forth with the x-axis till we get a little mark. And it should be kind of aligned. Depends on how square this is with the tool, of course. So you see we got a nice little mark there. Now we'll switch over to a center drill. We'll just visually line it up. We know, and you can see right there, we're pretty close to that mark that we did with that marking scale, the center scale. So it's almost dead nuts right on. So it works out pretty well. So really all you got to do here is hunt and peck it, you know, like a hunt and pecker. I don't need to hunt for pecker. I know where one is. That'll work. Center and drill it. The tap drill for a 3/8/16 is a 5/16. I hope that'll fit. That's the problem with not having an e-mill. You gotta make a good estimation of spindle quill reach versus tool depth. Oh yeah, we're good. Because a lot of times you get this thing lined up and then you go, crap, I gotta raise it up because I don't have the height. And it's kind of frustrating, but. Tighten the chuck, Mary. We're just going to send it and power tap it since it's not a blind hole and stop it before hopefully it crashes into the drill chuck. Of course, it'll probably slip, but who knows. Not too shabby, Daddy. Now it's rinse and repeat. Well, let's do a time warp. Yeah. .3/8/16 on each side. I need to calculate out the length I need to make those steel pieces because they need to be longer than the ones that on the original one because this is so much thicker. And then we'll be able to chuck that and then we'll get that cut and single pointed. See this block, I want to reuse these, so I need to make whatever that diameter is, I need to make the big part this diameter and then calculate how much I'm going to taper it down or bring it down to the 3/8 major diameter for that thread and then thread that part. Because we're gonna still use these blocks, so it's just gonna go inside like that, just like this one does, but with a bigger end that fits that. Here's the material I'm gonna use. This is actually an old drive shaft from a washing machine. I don't throw anything away. I like to repurpose stuff. That's why we made that big ring out of that piece of casts. This is the length of that 550 thou. This is gonna be the length of the threads. So we'll just do both of them about the same length of that larger diameter. And then we'll spin them both around and we'll cut them both down to 3/8 and then we'll do the threading operations one at a time. We're going to cut them back to about 82 or well probably 80 after we face it. 80 mil, that'll be the big part. That'll be about 540 thou. Whatever it is to take this, 540, 541, whatever works. I want this supported and I can't get in there with my carbide insert, threading insert, so we're gonna have to use this high-speed steel one, which I gave it some relief for something before, but the sides are still exactly at 60 degrees. It's a threading insert, it's a threading tool. So what I need to do is, what is this, 3/8/16? So what I need to do is I need to set the thing for 16 threads per inch, which is right down in here. I'm already at the 40, 86, and 40. That's why I didn't want to do metric. I'd have to change the change gears on the other side, on this side. So 16 threads per inch right there. So we want it at C1. So I'll go ahead and set that and we should be ready to thread. Really close, a little bit more, but it's going okay. Like I said before, I'm a novice at single pointing, so I'm learning as I go here. But all right, I think we should be about there. Just took a little bit more off, couple thou, I think that'll be fine, because I still got to knock the tops of those down a little bit, binding up a little bit. There's some burrs, you know, we got to knock them down with some memory or something. Yeah, that came out okay, considering I essentially don't know what the hell I'm doing. So yeah, but I'm learning. I'll wire wheel it off, it'll look fine, but let me do the other one off camera, then we got to do this, what do you call it, the pointed end. All right, so here's the finished product. Here's the one I've been using for a comparison. So you can see the inside is basically the same diameter. That's the one that counts. There's plenty of room on the outside because this thing is floating in the air essentially, way up top. The only thing that would limit that is, you know, the width of the two threaded rods, the all thread, and that really doesn't limit it. It just makes an adjustment necessary, but that's why I kind of did it this way. You kind of see that this is a little shorter, but I cut these down a little bit back, so this will go on a little further. But the trouble with that is I found on the pair that I just did, I still had to move this out a little bit for the all thread to catch, because the bar on the bottom needs some additional threads, some additional holes in it. That's this one here. You can see it's got threaded holes on each end for where the all thread goes down. So essentially what you end up having is you end up having this on top of that on one side and another one over here with the all thread in between them, and of course these guys like this. So it's basically like this. You have the all thread, and then this will go on top of it and pull it down, and this grabs that collar that's in there that has the two holes opposite each other for that purpose. That's like a spacer on top of the spring. All of them have something like that, because otherwise there's no way to preload it to get the thing back together. So what I'm going to end up doing is another day, I need to put a couple more, ½ inch apart or so. And this is 7/16/14, and just have some adjustability, because you know you don't really need to have it as far out as that, and that way you have some adjustability on this. So essentially the all thread is vertical instead of being cocked in. It'll work either way. I mean, it's not like it's really a precision operation. Yeah, so it worked, and I'm looking forward to trying it out again. Probably won't for a long time, but if I do, I'm going to try it out and see how it works. But that's it. So pretty cool. If you like what you saw, you know what you need to do. You stick around. We interrupt this outro with an important update. I've just been given this from the news department. I need to give it to you straight up. It reads, "But wait, there's more." Too much? Folks, this will be the revised outro. I'll make it short. Just like, well, never mind. You don't need to know about that. I decided to do a couple extra things to it, as you saw from the previous clips. Purely aesthetic, or mostly aesthetic. Yeah, definitely. We'll stiffen it up a little bit because that's a steel piece, but it's just from scrap I had laying around. My whole point was to make this out of crap that was laying around. Didn't want to buy anything. Everything you see here was just laying around here doing nothing. That, you know, the actual, you know, cast iron part, or I don't know if it's cast or ductile, I don't know what it is. But that iron part, that piece I just made, these ends, you know, again, that was from a washing machine drive shaft. So I like to keep stuff around and I make shit out of it when I need it. So this is definitely gonna last. There's no question about it. It's way stronger than this. Really happy with the way it came out. Yeah, absolutely overkill, unnecessary, but I figured I'd shoot some clips of it and show you, because, you know, I don't really mean to complicate things. Like, when do I ever do that? But, you know, the thing is, I just wanted to make it a little bit nicer. So that's it. I hope you got something out of this video. Hope it wasn't too long or boring for you. I like doing these little machine projects, and I'll continue to do them and put them up periodically as a midweek machining video. Till then, you need to stick around, subscribe, like, share, do all the stuff that you know you need to do. Thanks for watching. Catch you on next video.